Hello, welcome back to the channel, and today's video is going to be a SketchUp tutorial on how to create a dimensionally accurate 2x4 stud wall. Okay, so the idea behind this video is you have, I'm going to pull up some images, an actual wall where you need to model utilities going through it, like piping or electrical or anything like that, where you're designing and you need to be accurate dimensionally. You have this kind of sandwich of 1/2-inch drywall, your 2x4 studs, and then 1/2-inch drywall as well. That's what you can kind of see on the left here. And you can see this open wall on the right. And this is what you would need to show if you were planning things like electrical box locations for either switches or outlets, ensuring that there wasn't overlap in between rooms, things like that. So we're going to take a look at how to do that in SketchUp today. And I'm going to start with a floor plan of just 10 foot by 10 foot. It doesn't really matter. It doesn't really matter what you make the floor plan, as long as you keep in mind, let's see, that looks really small. Is this 10 inches? Nope, 10 feet. Okay. So it doesn't really matter, but the thing to note is if you're going to add studs to this space, but you took measurements inside a room, then you want to start building it out towards you. So let's say you had a room where it was actually inside the walls, inside finished drywall was 10 feet by 10 feet, and you want to model the room beyond that. Well, it's important to note, I'm going to use just this wall, but you can use whatever wall you need. It's important to note that when you have finished drywall, what you actually have is a 10 foot by 1/2, let me make sure I got the units correct there, 10 foot by 1/2 an inch sheet of drywall. That's standard. There is thicker drywall, but that's pretty normal for inside of a house, inside of a room. And then you have a 10 foot by 3.5 inch stud. And then on the other side, assuming the other side is getting finished as well, you have another sheet of 10 foot by 1/2 inch drywall. Okay. And you may have noticed when I put in the stud, which 2x4, right? That's the normal stud that gets used in interior, inside walls, especially non-load bearing walls. You'll get a 2x4. Well, it's important to be familiar with the fact that those are actually 1.5 by 3.5 inches dimensionally, because they get carved down from like raw 2x4. So if you're working in a house that's 100 years old, maybe you have actual true 2x4s. But anytime you're putting in modern studs and it's 2x4 walls, it's actually 1.5 by 3.5. You can Google that. I'm not lying to you. But okay, so this kind of drywall sandwich, which again, going back to the images, is what you have here. That's what almost every interior wall has, is 1/2-inch drywall, 3.5 inches of wood, and then another 1/2-inch drywall. And so we're going to start bringing this into 3 dimensions. We're going to ignore the drywall for now. I just wanted it to be there to be clear that, like you do, if you're trying to get down to 1/2-inch sizing analysis to make sure things are going to fit, wiring runs, piping, anything like that, be sure to include the drywall because it's there. So the first thing I'm going to do is I'm going to grab my extrude tool, the little arrow pulling out of a rectangle, because right now we just have this flat sheet of our 10 by 10 room and then one of the walls. And another thing to keep in mind, if your room is 10 by 10 and you want to model all 4 walls, you actually are probably going to want to extend these past the edges, but we're just going to do one wall for now. But right, because it's going to be 3.5 inches, well, it's actually 4.5 inches once you add the drywall in all directions. So you would actually want it to be 10 feet plus 4.5 inches on either side. I might do that in a future video. This one's going to be long enough as is. So this is your base plate. It's the bottom 2x4 that runs along the floor. And most of the time framers are actually building walls on the ground and then standing it up. And so that's why they would build it with a base plate and a top plate. But that's a long way of saying we're going to pull this up and we're going to pull it up 1.5 inches. So like we talked about, that's the size of a 2x4. And you can kind of see if you've dealt with 2x4s before, this clearly looks like one. You may notice when you extrude stuff that the backside of it can become empty. And the way you fix that is just grab your pencil tool and any one line of the hollowed out shape, just draw that line again and it'll become solid. Okay, so now we have a 2x4 just sitting on the floor where it would actually go. And we're going to start putting in our vertical beams. So let's say you have a 9-foot ceiling height, which is to finished ceiling. That's a pretty high room, but that's still fairly standard. Let's just go to the corner where it sits on the floor, because that's not going to be 9 feet from your base plate. That's going to be 9 feet from your floor. And we're just going to start drawing a line up just to get our dimensions, our sizing correct. And let's go 9 feet, okay? So now we have an arrow. Now we have a line that's up 9 feet, and I'm going to put one on the other side as well in the same kind of position. And that's just going to kind of orient us in the room so you can see this is how high our 2x4 wall is going to go. And so I'm going to connect those two, and then I'm going to delete out the screen that it kind of tries to make. But this should sort of show you the general idea of how the outline of our wall is going to look. So let's start dropping in 2x4s to bring it into the ceiling, bring them up vertical. So this is going to be 3.5 inches and then 1.5 inches. And you can just drag until you get that correct. I think it's way easier to do 3.5 and then the quotation mark and then 1.5 and then the quotation mark. And that'll give you, that'll give you a 2x4. Come on. Well, I said it was easy, and then I'm struggling, but 3.5, comma, 1.5, and then you should just be able to, I don't know why it keeps overwriting it. That should be all you have to do. Okay. And delete. All right, so there we go. We actually get it. It's supposed to be pretty easy. Anytime you drop anything that's on like a finished rectangle, so here we made this enclosure with the top, I'll actually get rid of that top so it doesn't happen every time I make a 2x4, because that's going to try to close off the space like we talked about. So then I'm going to just drop them on the sides for now, and this will also be 3.5 and 1.5. And let's get our outer two studs raised up. So you are always going to have a stud on the, or you should always have a stud on the extremities of your wall. On the far left and far right, it's pretty hard to finish drywall if they don't have a solid surface at the ends to anchor to. So you grab your extrude tool again, you pull them up to the 9 feet, which this is where making those 9-foot high lines is really nice because we have a finish point to extrude them up to. And just a little cleanup thing as you're going, you probably will want to go to where you extruded and just draw horizontal lines across your model. Especially if you're trying to show like individual studs where they'll start, where they'll end, because a lot of the times you can use a model like this as well for determining how much total material you have to go and get. So that's just my spiel there. But yeah, so now we have, okay, the outer two studs, and that looks pretty good. Let's do one stud on the top. So just like we have this bottom plate, let's do a top plate, but let's do it a little bit differently. Let's take right here. I'm just trying to show all the different ways that you could model in a stud. So let's say you wanted to start at the very end and just go vertically 1.5 inches. And then you want to come across to right here. And actually you can see it snapping. It's got from point, it's got the lengths in the bottom right over here. And so you can see it just made the end of a stud. And so we'll grab that rectangle just like we have every time so far, and we're going to drag it all the way to this end point, and it'll just snap in place. And so that was probably the fastest stud we've made yet. We check that we don't need to backfill and make sure it looks good. But just zooming out, we have this rectangle of our stud wall already going, and now snapping in the rest is going to be pretty quick. I'll show you how. There's this thing in framing, it's called on center, and all that means is like it should be a 16 is the most typical that I've seen for interior walls, is 16 inches on center for your stud walls. There are some materials where it's actually allowable. You can go up to like 24. Some people will overdo it and do 12. Some exterior walls, different areas, code is different. But 16 inches is pretty normal. They say on center, it's exactly the same thing conceptually as on right edge, on left edge. It doesn't matter. It just means if you are at the middle of a stud and you go 16 inches, you should be at the middle of another stud. So that's me being long-winded, but for this first one, since we're on the right edge of a stud, I'm going to take a line from that midpoint, make sure I'm going at a right angle, but I'm going to go 14.5 inches for this first one, because just like we talked about, right, a stud is 1.5 inches wide, and right now I'm just marking where all of them should start. So I'm going to go 14.5 inches, and then from there on, I'm going to go 16 inches. And every time I finish a line, I'm going to go up and down, and then I'm going to go back at the very end and clear out these. Well, I guess I'm doing it right now. And I'm going to clear out those marking lines. So this is just kind of my like cheat for doing quick measurement. I just will put down a line and I'll make it however long I need it to be. So for studs, it's 16 inches. And then I just mark it vertically. I kind of make the crossing line, and then I delete out those lines I used to mark it. So I'm going down this model and just every 16 inches putting a marker in. And what you'll see is you're typically never going to be 16 inches from both ends unless it just worked out really nicely that you have a room where, it's some multiple of 1.5 feet or 1.33 feet, whatever, where it's some nice multiple of 16. So you can see right here, all these gaps are even until you get to the very end. We're a little close to the right. You could use that concept to design something that's not that way. But I'm just going to leave it. So 3.5, 1.5, and it's very normal that you're going to have 3.5, 1.5 for all of these. It's very normal that you're going to have a not 16-inch gap on both sides. It's better to leave that gap uneven than to make your studs some unusual spacing. Like you could say, oh, well, if I would cut all of the spacing down to 14 inches, I would get an even 14-inch gap here too. That's kind of incorrect because you want your studs to be spaced at a standard sizing. I probably will have some DIYer in my comments like, I do even spacing all the time. I don't care. So we're going and we're dropping in the footprint of our 2x4s, and then once they're all modeled in here, we're just going to grab that extrude tool, and this part's really satisfying. We just grab them, we pull them up to the bottom edge of our top plate, which is why we made that early. And we're going to do that for each of them, and it only takes, a couple seconds. And you'll see, like, SketchUp loves to snap to things that make sense to it. So it'll give you, Control Z. You can always Control Z to undo, just like you can with the Word doc or any other thing. And SketchUp will usually snap to exactly what you need to get to. So there we go. All right, and that's pretty cool. One thing that we do have is we have to just come down and put a horizontal line in across those studs. You could do them all individually. It's way faster to do it this way and just delete out the panels that it tries to put in. And now, like we were talking before, you can see all the individual studs. We'll come over and do it for the other side too. And if you're a builder just starting to get into 3D modeling, this probably looks very familiar to you. If you've never seen an open wall and you're just kind of getting into like interior design or planning, then this is maybe new to you, but this is pretty much what a wall looks like when it gets framed in and lifted up. So let's say that there's a door going in this wall, because every room is going to have at least a door, and if you can do this process for the door, you can do any window as well. It's very similar, just a little bit easier in my opinion. So let's say for door placement, you were just instructed put it in the exact center of the room, and let's say it's a 32 by 80 door, which is a pretty standard interior door. Okay, so we're going to just make a line that's 5 feet, just so we have a midpoint reference. And I'm going to use my little cheat markers to say, okay, that's the midpoint. You probably already had in this model, excuse me, in this model a midpoint marker if you had gone with like this line from the drywall that we put in, but that's okay. We made a new one. Now, I said it was going to be a 32 by 80 door. Here's where having some knowledge of houses is important. When you do a rough opening, which means you're framing in a wall, you actually want to add 2 inches to both dimensions for your rough opening. So 32 by 80, you're actually going to make an opening with your 2x4s that is 34 by 82, and that's so that you have space for the trim, like the door that gets hung on its hinges and then put in frames that stop it and have the little spot for the latch. That takes up an average of 2 inches, and whoever's hanging your door is going to give you like, okay, well, it's a 32 by 80 door. And a real framing person who knows what they're doing is going to add 2 inches to both of those for the rough opening. So there's my spiel about doors. But let's go ahead and say from that midpoint that we made, that means we're going to add 17 inches to either side for a rough opening. And then we're going to mark those edges. And then we're going to clean up everything in the middle. So we don't need these anymore. Not really. And I'm going to put in the new studs before I remove the old ones to show you what we're doing. So the right at the limits of where your door is going to go, and I'll go ahead and put my stud rectangles in here. Right wherever your door is going to go, you're going to have 2x4s to the left and to the right of the rough opening. That's what they're going to get mounted to, but you don't always bring these all the way to the ceiling. They're actually called jack studs. And you house people on the internet can check my terminology, but they just go to the height of the door. So if you think about this, the rough opening is supposed to be 82 inches from the ground. It's sitting on a bottom plate that takes 1.5 inches of that. So the height is actually going to be 80.5 inches from the top of your plate. So I'll extrude those real quick at 80.5, and then I'll talk about what we did. I'm going to clean these up just like always. Okay. And if we zoom out, what you're going to notice if I grab my measuring tape is that from the floor to the stud that we just dropped in, okay, it is 6'10", and that's 82 inches. Let me make sure 72, 82. Yeah, 82 inches. Okay, so that means that we made these studs at the right height for the door opening, and the reason you need these to not go all the way up to the ceiling is this also changes whether or not structural. I should probably put like a disclaimer in here, like I'm not going to act as your licensed structural engineer, so nothing I say in this video should be taken as absolute fact. Don't sue me for anything. But if this is not a structural wall, then you can just put a flat 1.5 inch 2x4 on top of this guy, and you don't need to make it like a beam that can carry significant load. A flat plate, just like what's down here, will work. If it's carrying any kind of load or you're not sure, then what you should do is make a little beam sandwich where you take a 2x4, put it on its side so it's actually 1.5 inches by 3 inches. I'll just come in here and model it real quick. This is already a long video. So what you're going to do is you're going to put a 2x4 on its side, and that's going to be this first 1.5 inches. And then you're going to put a strip of like 1/2 inch plywood or something, wood, in between them for 0.5 inches. And then you're going to put another 2x4 for this last 1.5 inches. And you're going to make that little beam sandwich, and it's going to be 3.5 inches, and you would set it up here on its side, and that's how you would add like some structural strength to it. That's how you'd make a mini beam. I think it's called a lamb beam. But if this is not structural, you don't have to worry about that. So we're going to model it this way: flat bottom plate. We're going to extrude it. We're going to bring it all the way to the right edge of our doorway. And you don't have to worry about these crossers, because now what you can do is grab your mouse tool and you're just going to start deleting out the elements that are in the doorway. And since we made our top beam already, we're not cutting out the stuff above, which is going to make our lives really easy, which I'll show in a second. So just clear out everything you had made that's now inside the doorway, and delete out these extra lines in your header beam. Delete, 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 delete. I'm not going to say delete every time. I'm not going to do it. Delete and delete. Okay, and the last couple things you should draw in, because you notice your verticals got cut off here so they don't look like 2x4s anymore. Go ahead and draw in the feet. I don't know if feet's the right term. Go ahead and draw in these bottom lines so that they'll fill in. But I'm going to zoom back real quick, so I'll clean up these lines as well. But you see, we just put a doorway in, and this is sweet, but we have to add what's called the king studs. So those were called the jack studs, right? The ones that kind of define the doorway opening. The next thing we're going to do is called the king studs. But if you've ever seen a doorway, you've probably noticed that you don't have to step over a 2x4 to get into it. That's because both sides of the doorway get independently screwed into the ground. And then we can go ahead and, ooh, I got to put my bottom lines in there too. So if you did frame the wall, you probably did do one continuous piece of wood across the bottom. Well, once you stand it up and screw it into the floor or nail it into the floor, you can cut out this middle point inside the door, because both sides are independently mounted to the floor, and then the top plate is going to be mounted to the ceiling. So you go ahead and clean that up, and now you have a doorway. Okay, so that's pretty cool. Let me grab my mouse tool again and get out of here. Oh boy. There we go. All right, clicking trouble. Okay, so the king studs are what go right next to the jack studs, but they are floor to ceiling 2x4s. So this is pretty easy to model. You just come in right next to your jack studs, and you make another 3.5 by 1.5, and you put that on both sides. And actually, what's neat about this, there is exactly an 1.5 gap between just the 2x4 that would have been there on center. This gap's 1.5 inches. I didn't plan it that way. Some people, some builders may just put little blocks of wood in between these two, because it's kind of overkill to put another 2x4 here. So you could put little 2x4 wedges in here and just screw it in 3 or 4 places. The purpose of this is so that your doorway has vertical support all the way floor to ceiling, and it can't wiggle side to side. I also didn't mention it. The name of these things that go from the top and maintain the 16-inch on center, those are called cripples, and they go in above your doorway to maintain the 16-inch on center spacing, which is important for like running electrical or anything like that. So we are going to go ahead and put the jack studs in. I'm just going to do it to show that you need to have some kind of support here. So this is called a king stud. It goes right next to your jack stud, and it runs from the floor to the ceiling. And you're going to make sure that this is screwed laterally into your jack stud a few places too, because normally for these studs you're just putting them in the ground and then you're putting them in the ceiling. There's also, if you have a room that's like above standard height, so say these were 10-foot or 12-foot ceilings, and if you don't want to worry about getting like perfectly straight 2x4s, or you're worried about warping, you can put cross bracing in here. So you could put little spacing 2x4s throughout this and attach them horizontally, and that would kind of prevent side to side movement. We're not going to do that for the purposes of this video, but what you can see here is we have kind of this perfect structural modeled wall showing all the 2x4s required plus a doorway. One more thing that I wanted to do real quick, because we made our drywall rectangles in the beginning, it'd be a shame not to use them. I'm going to go ahead and grab one of them. I'll grab this back one, and I'm going to pull that up to the top. And I really wish actual drywall got mounted that easily. But so I'm going to take this doorway. I'm going to click on the rectangle inside the doorway, and I'm going to use my extrude tool to punch it through to this face, and it just automatically cuts out the drywall for that opening. So if I grab my measuring tape, we'll remember that we needed the rough opening to be, what did I say, 32, 24. This is 34 inches. We're doing a 32-inch door. Yeah, okay, perfect. And then we needed it to be 84 inches high. No, 82 inches high because the door is 80 inches. Sorry, I'm getting confusing myself. It's been a long video. But this is perfect. The last thing you can do, this is going to help yourself as much as it's going to help anyone you may pass the model to. Check and see if you have any like straggler lines and just clear them up because you don't want confusion. So lines like these that are left over from 2x4s that we deleted out, anything like that, make sure every 2x4 has a base plate. And then one nice feature of SketchUp, you can go into this materials tool on the side, go down to wood, grab one that just kind of looks plain, doesn't really have to be anything special, and just start filling in everything that's wood. And you can either leave the drywall as white or you can give it a special color. If you're going to make a legend that says like blue is drywall or something, you can do that. But this also makes your model like really easy to understand, so you can take a look at this model and just instantly know where the different materials are. I pretty much always add texture to a model, especially if I'm showing it to anyone else or helping like a builder understand like where things are. And it goes pretty fast because it's basically just like paint. It gives you a little bucket. You click whatever surfaces you want filled in. I'm not going to spend too long making sure I caught every little rectangle. Oops. I maybe need surface there. Interesting. Okay, so we're just going to go with this because I'm at like a half-hour video already. But the next thing you could do from this now is you could model in all 4 walls. You could throw electrical in here. You could throw plumbing in here. You could throw anything you needed to in here. You could model ductwork and ventilation coming through. So that's the basic concept of how to make a dimensionally accurate, structurally correct 2x4 wall. And I'm not going to pull it up because if you were to just cover this, then like what would the point of putting the 2x4s in be? But you could pull like the drywall potentially halfway up just to show it is going to be a covered wall. And then you could start layering it, so you could basically give other people the permission to, I'm going to just undo that. You could give other people permission to delete entities and view things that are inside your model. But for now, I think that's everything you needed in this video. I hope you found it useful. If you are enjoying the SketchUp tutorial series, be sure to let me know about in the comments below. If there's something specific you'd like to see in a future video, let me know about that as well. Be sure to check out the channel and subscribe to stay up to date with all the new stuff coming out. Just be sure to leave a like, subscribe to the channel if you found any of it useful. It's a pretty new channel and I'm just getting started out. So I really appreciate your support. And as always, good luck with your projects and thanks for watching. Thanks. Bye.